Good day, everyone. We are here again to study and learn physics. Just like our previous video lessons and virtual experiments, the video lessons here are designed to help students gain knowledge in the specific topic with minor support from the teachers. The discussion is made simple, but in order to attain the objectives of the lesson, you have to complete the video to the end. Today, we will perform a virtual experiment on the first condition of equilibrium. The objective of the experiment is to verify the first condition of equilibrium. To attain this objective, the following materials are needed: the dynamic heat stand, pulley system with clamps, hard cardboard, protractor, ruler, pencil, and hook weights. What is the theory of the first condition of equilibrium? The first condition by which an object remains at equilibrium, either at rest or in straight line motion with constant speed, states that the net external force acting on the object must be zero. Any object hangs at rest if its weight is counteracted by other forces, so that the vector sum of all concurrent forces along the vertical and the horizontal directions is zero. In this activity, the weights hanging on the left, right, and center objects are considered tensions on the left, right, and center chords. If the system remains at rest, then the sum of the upward components of the tensions in the left and right chords is equal in magnitude to the center object's weight. Likewise, the leftward component of the tension in the left chord is equal in magnitude to the rightward component of the tension in the right chord. Let's proceed to the experiment. The experiment is divided into two parts based on the method of determining the resultant vector. The graphical method, and the other one is the analytical method. First is to set up the dynamic heat stand with clamps and pulley system as shown in the figure. Hang a number of weights on the left, center, and right chords, such that the center weight is less than the sum of the left and right weights. Give the system a little jerk and let it come to rest. With the use of hard cardboard, trace the lines of the chords on the bond paper similar to the figure shown. Count and record the number of weights in each chord. In the succeeding video clips, watch silently how the experiment is performed. This is the actual setup of the dynamic heat stand, pulley, thread with loops on both ends and in between for the left, center, and right weights to hang on. Watch these video clips. Now, to discuss further how to perform the experiment, let's consider the traced lines and the number of weights. The left L is 3, the center C is 5, and the right R is 4. You have to measure the angles between chords left and right, or angle LR. Between right and center, angle RC. And between center and left, angle CL, using the protractor. This is the angle between the left and right chords. It measures 100 degrees. This is the angle between the right and center chords. It measures 140 degrees. This is the angle between the center and left chords. It measures 120 degrees. After measuring all the angles between the three chords, what is the sum of all the angles between the chords? How will you check if you measured the angles correctly? With a convenient scale of unit length for every weight, 2 cm equals 1 weight. Record on the table the number of weights, the length of traced lines, and angles formed by the left, right, and center chord. Table A. This table shows the chords, the number of weights, length of traced lines, and the angles between chords. Reconstruct the vectors formed by the three chords following the length of traced lines and the angles between chords using the graphing paper. On the graphing paper, reconstruct the vectors formed by the right, left, and center chords using the ruler to measure the length of the vectors equal to the traced lines on the table. Vector R, vector L, and vector C. These are the vectors. The second part of this experiment is the analytical method. Measure the direction of each vector from the positive x-axis and record on the table. The direction of the right vector, the right chord, theta sub r, is 50 degrees. The direction of the left chord, or the left vector, theta sub L, is 150 degrees. And the direction of the center vector, or the center chord, is 270 degrees. Determine the sum of the vectors graphically. Polygon method. Following the vector equation, vector sum equals the right vector plus the center vector and plus the left vector using the graphing paper. Draw the x and y axis. Plot the right vector, the center vector, and the left vector. Draw the closing side of the polygon. This is the resultant. if the tip of the left vector fall at the tail of the first vector, which is the right vector, then the resultant is 0. But if not, measure the length and direction of the resultant vector using ruler and protractor. The length of the vector sum is 0.9 centimeter. The direction is 270 degrees. Determine the sum of x and y components, the magnitude and direction of the resultant. Show the computations, record on the table. The x component of the left vector is equal to the magnitude of the vector times cosine of the angle of the vector from the positive x axis. Substitute the magnitude and direction. The cosine of 150 degrees is negative 0.866. Thus, the x component of the left vector is 5.196 negative. The y component of the left vector is equal to the magnitude of the vector times sine of the angle of the vector from the positive x axis. Substitute the magnitude and direction. The sine of 150 degrees is 0.500. Thus, the y component of the left vector is 3.00 centimeters. Determine also the x component of the right vector. The y component of the right vector, the x component of the center vector, and the y component of the center vector. After computing all the x components, find the sum. After computing all the y components, find the sum and record. Calculate the magnitude of the resultant using the Pythagorean theorem. Determine the direction of the resultant vector based on the quadrant location of the resultant. If it is on the first quadrant, this is the formula. Record all the computed components and resultant in table B. These are the values computed. Based on the sum of x and y components, the resultant vector is not 0, but is acting on the third quadrant. The direction of the vector when at the third quadrant is 180 degrees plus the inverse tangent of summation y divided by summation x. Determine the precision of performing the experiment by computing the percentage of difference between the magnitudes and directions using the graphical and analytical solutions. Record in the table C. This is the table. This is the formula for the percent difference. And this is the precision formula. After computing, this is the result. Now for this experiment, this is the setup where you will gather the data. Take note of the number of hooked weight hanging on the left, right, and center cords. When traced, the right, the left, and the center chords. In these traced chords, measure the angle between the vectors. The angle between left and right chords. The right and center chords. And the center and left chords. Record the measure of each angle. If you need more time in reading the measures or the angle, you may pause this video. Don't forget to play again to continue with this experiment. Measure the direction of the vectors from the positive x-axis. Record the measure of theta sub r, theta sub l, and theta sub c. Should you need more time in measuring, you may pause this video. Don't forget to play again to continue in this experiment. For additional instructions for this experiment, record all the angles measured in Table A and Table B. Plot the vectors using the graphing paper A. Determine the vector sum graphically using the graphing paper B. Compute the x and y components of each vector. Sum of x and y components, magnitude and direction of the resultant, present difference, and precision. Show all the computations needed. Record in the tables. Complete the report and submit to your instructor or professor. Before this virtual experiment ends, the author recognized the entire physics department. This interactive online activity was adapted from the laboratory manual developed by the faculty in the department. Modifications were made to fit as an online activity to respond for the need due to the at present unfavorable situation. The video clips in these video presentations were cropped from the videos recorded by Professor Nelson M. Abana, head of the department, Professors Danilo B. Olete and Richard L. Muhi. Hoping that you have met the objective of this virtual experiment and learned from this interactive video presentation. If you learned from this video and you feel that other students may also learn from this, like and share this video. Don't forget to subscribe to my channel for more learning videos are coming ahead. Thanks, God bless, and good luck.